Assalamualaikum and hi. Today I will explain about Euclidean space and Euclidean inner product in chapter 1 for linear algebra. Let's learn it. Euclidean and space. The fundamental space of classical geometry. Originally, it was the three-dimensional space of Euclidean geometry, but in modern maths, they are Euclidean spaces of any non-negative integer dimension, including the three-dimensional space and the Euclidean plane. If n is a positive integer, then an ordered n tuple is a sequence of n real numbers a1, a2 until an. The sets of all ordered n tuples, which is a1, a2 until an, is called n space and is denoted by Rn. Rn, n is natural number called dimension of the space. If A is a vector, so the element in this bracket called component. A is a vector, so this bracket is called component. If A is a point, the element we call coordinates. For example, R1 is referred the real line. When n equal to 1, each ordered n tuple consists of one real number, which is a1. This is the real line. So the next is R2. It's refer the plane. When n equal to 2, it is customary to use the term ordered pair. Is a1, a2. It is a1 and this is a2. And we can put the number Next is R3. It refers three-dimensional space. When n equal to 3, it is called ordered triple. Is a1, a2 and a3. And this is a1, a2 and a3. And it is the origin. So we can put like this. And so on. Okay, next is difference between Hilbert and Euclidean. For Hilbert, spaces usually applied in the context of infinite dimensional vector spaces, but Euclidean spaces have the constraints to be defined in finite dimensions. Next is difference between vector and Euclidean. Euclidean space can be any dimension and is based on coordinates. Vector space is a structure composed of vectors and has no magnitude or dimension. Okay, the next we learn about Euclidean inner product. It's also known as dot product. When n equal to 2 or 3, the Euclidean inner product is also called the ordinary dot product. If u bar equal to u1, u2 until un, and v bar equal to v1, v2 until vn are any vectors in Rn, so that the formula can be written as u bar dot v bar equal to u1 v1 plus U2 V2 plus until UN Vn. For the example is actually you're supposed to have two vectors, which is x. The example we can use x equal to x1 x2 and y equal to y1 y2. Okay. Then we use this. So it's become x1 y1 plus x2 y2, and this is the inner product, so it just multiplies itself. Okay, for this one, if they would have been n dimensions, suppose x projected to n-dimensional vector and y is also n-dimensional vector, so this multiplication would be like this. That's all for this video.